One, two, three, one, two, three. We are at Inside Quantum Technologies, and I'm here with one of my favorite members in quantum technologies, Qunnect. Noel Goddard, CEO of Qunnect. What is Qunnect?
Qunnect is a company that's trying to turn standard telecom infrastructure into quantum networks by developing the hardware to support entanglement distribution.
In one of my previous videos, I went all the way to New York City and you showed us how you actually already deployed your technology in a fiber-based area.
For the first time ever here in New York, we have a fully functional testbed of distributing quantum entangled photons, which you can literally see it live on the monitor right now. And the experiment is right behind me, that we are sending very high purity, high rate entangled photons in the fibers in New York City, the fibers that are going to Brooklyn, to Queens for 35 kilometers and coming back here. And we show that we can preserve high rate, we can preserve high fidelity with a very uptime of the network, bringing this entanglement distribution much more closer to practical applications in metropolitan scales.
This is the first quantum network of its kind in the United States.
There are a lot of firsts, and all these networks, like everyone is doing something differently, so it's very fair to call all of them first, but this is truly the first time that we are very practically distributing very useful entangled photons that are generated to be very compatible not only with telecom infrastructure, but also with different quantum devices, quantum computers, quantum memories, quantum sensors, so we can go beyond the basic application of quantum networking, which is the quantum encryption and key distribution, and go towards this dream of quantum internet, distributed computing and sensing.
Can you explain us a bit more about this?
We're really excited to stand up really the first testbed in America, which is actively distributing entanglement through real telecom fiber. So the first segment of it is this 34-kilometer loop that runs through all of the coolest neighborhoods in Brooklyn and Queens. And then we built a second segment to one of our partner institutions, which is New York University. And we have coming in the next year some announcements about connecting to some data centers in downtown Manhattan, as well as some of our partners out in Long Island. And the entire idea is to learn how to use the fiber, which is in the ground today, to distribute entanglement for real using our hardware, which we're now starting to package into these systems.
The idea is to provide a rack, and you were the first company worldwide to commercialize a quantum memory.
So the quantum memory we're very proud of because it is the cornerstone of being able to extend distances in networking. But even over metropolitan distances, I think that we're still first movers when it comes to developing system-level approaches to being able to distribute this with very high fidelity.
Yeah. So what are the next challenges?
So for me, it's sort of twofold. One of them is how do we, as a company, start to scale types of instruments which are very difficult to build. So the idea of manufacturing, that's always a challenge which I think is in front of us, but it's one that we can meet. The other one is use cases. So one of the things that we wanted to do by building this network was to have the opportunity to actually invite other people to come and use our network to see if, again, these networks would be useful to them and their types of businesses. So we have defense contractors, telecom service providers who are coming to actually use our network to test our equipment and their systems. And also the idea of being able to distribute our instruments out to strategic partners. So we have strategic partnerships with government agencies, with private telecom providers, with some universities, all of which are doing some tests over protocols and other things.
Noel, you have made a really big difference by always bringing demonstrators everywhere you go. At OFC, at the OFC Net, then you were also here with all your demonstrators in New York the day that you launched that demonstrator. How can we attract more end users to this community?
I think that the challenge has always been that they don't have something to test. So one of the things that Qunnect always believed in was the idea of trying to get a systems-level approach which was turnkey in order to meet the demands of an end user. So by getting the first systems out, we believe that then those users of research systems will tell us the types of protocols that they would like to have for more sort of specific use cases. We're going to start building protocol-specific racks to users' needs in the 2 years to come.
We meet in different parts of the world every few weeks, and a few weeks ago I met some of your colleagues at OFC. Right. And there it was all about AI. How do we link the quantum industry with the AI hype?
So you know our tagline, right? Hardware not hyped. So I have to say, for whatever it's worth, my tendency is that I feel for us to actually get into quantum, we need to focus much more on the first step to get the hardware there. But in terms of integrating AI, all of the instruments in quantum, they all are extremely sensitive to alignment difficulties, very active environmental perturbations, etc. These are areas that lend themselves sort of naturally to machine learning and AI in order to improve performance.
Noel, I would like to congratulate you first on the huge developments that you're doing. Second, on positioning Qunnect as a global company with an office, for example, in the Netherlands. And third, by attracting end users to the quantum industry. Thank you very much. It's great to have you in Optica. The first corporate member in quantum technologies at Optica was Qunnect. Thank you so much.
Thank you.
Oh, it's really cool. You're a natural.